Welcome, esteemed guests. Here's the stitch. Back in 1880, our good friend Pyotr Ilyich Tchaikovsky composed the year 1812 Solemn Overture Opus 49, more popularly known as the 1812 Overture. According to everyone's favorite primary source, Wikipedia, the 15-minute overture is best known for its climactic volley of cannon fire, ringing chimes, and a brass fanfare finale. It has also become a common accompaniment to fireworks displays on the United States Independence Day. In noting this, we, the members of the United Nations of Physics, have allowed for an even more astonishing climax. Under the pretense that our cannon is placed upon the uppermost steps of the Franklin County Courthouse, and that the Hampton Municipal Band is performing this most elaborate of overtures during their July 4th concert, the stage has now literally been set for the projectile motion problem to end all projectile motion problems. Now for the math. To begin with, we know that the steps of the courthouse are roughly 2.5 meters taller than the floor of the bandshell. We also know that the distance between those two settings, or rather to the exact place where the director will be standing, is approximately 123 meters. The last cannon fire called for in the overture occurs during beats 1 and 2 of measure 404, and the fermata at the very end of the song begins a mere 72 beats later. A little cross-multiplying and dividing, given that the tempo of the song is 168 beats per minute, tells us that the cannonball needs to land exactly 25.71 seconds after it is fired. Knowing this base information, we were able to derive the rest of our variables by first doing the quadratic equation backwards, since we had already solved for time. This yielded a result of 126.01 meters per second as our initial velocity in the y direction. Taking our change in distance in the x and dividing it by time, we also find that our initial velocity in the x direction is 4.78 meters per second. A little right-angle trigonometry allows us to find that our initial velocity without a set direction is 126.1 meters per second. We also find that our launch angle must be approximately 87.84 degrees in order for this grand scheme to ultimately come to fruition. As the final pieces of this puzzle come together, solving for t when velocity in the y equals 0, we find that our y max occurs at 12.85 seconds after firing, and that our cannonball's peak height reaches almost that of the Burj Khalifa's at a whopping 811.8 meters, or just over half a mile into Earth's troposphere. As our final calculation, the cannonball's velocity at the instant before it hits the director's podium is negative 126.21 meters per second, which we believe will give him such a shock that his toupee will come flying off his head and into the band itself. This leads directly into our second projectile motion problem, where in some completely arbitrary numbers brought forth by Jake, he certainly did not follow the same steps as before, given the same set of solved variables, only with differing values. That would be insane. Why would you even suggest that? And by following the normal set of procedures, i.e. solving for time instead of being given it, and following the natural progression of variables from there, we eventually find that the change in x for the toupee, which just happens to land exactly as the fermata and song as a whole come to a close, will plop itself upon the noggin of one particular individual seated exactly 3 meters from the director, that being Mr. Carl Wayne Kurth. As this overture comes to a close, we simply wish for you to reminisce upon the knowledge shared with you today. For if a group of teenagers can theoretically launch a cannonball over Highway 3 perfectly in time with the director over a football field away, nothing is impossible. The sky is quite literally the limit, as when it comes to physics, you can let your imagination run wild.